Hey, this is René. Welcome to another video on this channel. And today we will write a function that can calculate a lot size, which is based on a percentage of your account. So you can place any trade like a buy limit or a sell limit, for example, and maybe you want to place the stop loss down here. But before you do all this, before you place the trade and the SL, you want to know how many lots, oh, this was not correct, I have to put the stop loss, how many lots you have to choose for this specific trade. So for example, you want to risk like 0.5% of your account, which is in this case roughly 8,500 US dollar. So you will have to open, for example, 0.68 lots to be able to open the trade here and place the stop loss here and risk in total 0.5% of your account. So to calculate this, you will have to do some mathematical calculations, and this is what we will have a look at now. So first of all, when we try to program something, we first of all have to open the IDE, the Integrated Development Environment, which is the meta editor. And we will now create a new expert advisor. If you click on new in the upper left corner, you can do so. And we can choose a name. We can choose, for example, test, or we can say variable risk or percentage risk. Yeah, it doesn't really matter what name you choose. And then you click on next, next, and finish, and this will create a expert advisor for you. And we want to write a function this time. So in any expert advisor, you will find these three base functions, which are system functions. And these functions are called by the MetaTrader itself. But we are also allowed to create our own functions. And it always works like this. You have a return type, which could be integer, void, or in this case, double. This just means if the function is called and after it is processed, it will return one value, and exactly one value. And you can define the type of this value here before you define the function name. The function name could be calculate lots, like this. So make sure that you define this function outside of any other function. So this is outside of any other function on a global scale. So first of all, we have the return type, then the identifier or name for this function, or however you want to call it. And then we have the parameters, which are in parentheses after the name of the function. And then we have the body of the function. So if you compare this to, for example, the onTick function, you see the build is pretty much the same. So we have this return type. Void means nothing in this case, but in this case, for the calculate lots, we want to return a double value because we want to have the lot size, which could be something like this, or like this, or like this. So we need a double value. Then we have the name for this function, which is calculate lots, but you could say anything. You could say my dog is named Pete. It would also work. I mean, I can compile this and there's no error. But it makes sure that it makes sense to choose a name that actually says or tells what the function does. Okay, I lied here. There is an error because we did not return anything. But if we return, for example, any double value and compile this, the error is gone. Okay, so what we do here is we now go inside of the body of this function, and the body is always between these curly brackets. So please make sure that the parameters are wrapped in round brackets and the body is wrapped in curly brackets. So in this calculate lots function, we first of all have to get access to some parameters of the symbol that we are trading. For example, the tick size. And the tick size can be received using the symbol info double function, like this. And we can then provide a symbol, which is the chart symbol in this case. And if you write this comma, you can see there are a lot of things already suggested. And we have something like symbol trade underscore tick size as a identifier for the parameter that we want to receive. So these symbol info double functions, and you can have a look at the reference by clicking F1 on your keyboard, you can see this will return a specific property for a symbol. And you can see, first of all, you will have to provide the symbol, and by providing this underscore symbol system variable, we always choose the chart symbol. I can show it to you in a second. And then we can have the symbol trade tick size identifier to say, from this specific function, we want the tick size for this symbol to be returned. And we store it in this variable of type double. So if we, for example, print this, the tick size, you can see if we now activate the program in the chart, it is this percentage risk, and you can find it now in the MetaTrader and the navigator. If you click under expert advisors, there you will find this percentage risk. I can drag and drop it or double click it on any chart. And if I click on OK, you will see that nothing happens. So we do not get anything in the expert's journal. And this is because we first have to call this function. So as I told before, these three functions are system functions, and they are called by the MetaTrader. For example, if the program is initialized, the onInit function is automatically called. But this is a custom function that we built only for our program. So this is not called by the MetaTrader itself. So we will have to place it or call it inside of any of these system functions. So we can say calculate lots shall be called here in the onInit function. So you write the name of the function, then the parameters. In this case, there are no parameters, so we put empty parentheses, and then we have this semicolon to end the line. And this is a complete statement that calls the calculate lots function. So once the onTick function is processed, the PC will realize that we call a function, and it will then search for this function in the program, and it finds the function here. So at this point, it will just process the body of this calculate lots function. So if we compile this, we will now see something is printed down here in the expert journal, and this is the tick size. The tick size means what is the smallest possible price change pretty much for this symbol. And you can see there are 5 numbers after the decimal point. So a tick size is 0.00001 because this is the smallest price change for euro US dollar, and we will need this later on for the calculation of the variable lot size. So now we need some more things. Of course, we have to know what the value of this tick is. So we have to know what it's worth. So we can say we write exactly the same. But in this case, we have a different identifier, and it is not tick size, but it is tick value. Everything else stays the same. So if we add this to our print statement here, you can see that now we see whenever the price moves by 0.00001, and we are invested with one lot, this will make a difference of $1. So we can, if we just trade like one lot here, you will see if the price moves, it will make a difference of $1 for every single tick. And this is what you can see here. So this is what we just calculated. So we received the tick value, which is this, and the tick, the tick size, which is the first number, and the tick value, which is the second number. And you can do this, by the way, for any symbol that you like to trade. For example, if we attach this program to the Australian dollar, Canada dollar, I think. So if we attach the program to this chart, you will see the values, or at least the second value, should be different. So if we, oh no, this was the wrong program. We have to choose this percentage risk program. So if we attach it here, you can see the tick value doesn't really make sense, or it was not loaded yet. Okay, so it takes some time to receive the value from the server sometimes, but in this case you can see the tick value is still 0.00001 because five numbers after the decimal point, but the tick size is now different. So you can see this works for any symbol pretty much. So this is why this method of calculating the risk is so good, because we can just use these symbol info double functions for any symbol. And now we go ahead and also calculate the lot step, and this will be important later on. So we use symbol info double underscore symbol volume step, and this is, yeah, we can print it here, lot step, and this is the smallest change in the lot size. So this is 0.01. It is, for most symbols, it is 0.01, but there are some CFD contracts, for example, where it is 0.1 or 1.0. So this is like the typical change of lots. So for example, here I can do something like 1.01, but if we have a look at something different, wait, let me open something here. Hello, where are my market watch, I think. So if we open some CFD contract, I think it should be different. Let's add the license. Oh no, wrong program again, the percentage risk. If we click on OK, you can see now all these values change, and especially the last value changed, the lot step, because, or the volume step, however you want to call it, because in this case, I am not allowed to trade 0.01 lots. You can see if I change the lot size here, it always is in 0.1 lots steps. So this is what the lot step or volume step is about. Okay, so now we have these three values, and this was just for the calculation later on. So what we will do now is we can first of all check if the tick size is equal to 0, or if the tick value is equal to 0, or if the lot step is equal to 0. Because in this case, something failed. So we should not go on with the calculation. So in this case, we can just return 0 because something didn't go right. And we could also add some print statement here. Function, we can say, for example, lot size cannot be calculated. Like this. Okay, but if we are able to receive all these three values, we can go on with our calculation. So first of all, we will have to figure out now how much we want to risk. So we might want to risk like 0.5% of our account. So we can provide this to the function as a parameter. So we can say in these round brackets, we say risk percent, like this, for example. And of course, we can now use this variable in the function body to make some calculations. So what we can do here is we can say we want to calculate the risk in the account currency, so risk in money. So what we can do here is we can take the account balance, and you can either choose balance or equity, whatever you prefer. And then we can multiply this with the risk percent and divide it by 100, because this is how to calculate the risk in money. So we can say risk money, we just print this, and now we will have to provide, if we now compile this, there's an error, because we still call the calculate lots function, but we did not provide this parameter. Since we added this parameter here, we will have to provide a value for this. So we can choose, for example, 0.5 or 1.0. This is easier to calculate. So now the program, it will print 85 dot 7626, and if we have a look at the account balance, this is exactly 1% of this of the current balance. So this is how you can calculate the risk in your account currency by using like this line. Oh, and the account info double function, it is pretty much built like the symbol info double function, but it of course returns values or properties of your account and not of the symbol. And you do not have to provide a first parameter like this underscore symbol, obviously, because there is only one account. So the account that you currently use where you're logged in, it will be chosen for this account info double function. Okay, so we calculated the risk in money. Now we will have to calculate how much money we would lose if we would trade a specific distance, like what I tried to explain in the beginning. If we have like this where is it? Buy limit. If I add a stop loss somewhere here. So we have a distance between the entry and the stop loss. And this distance, it is a specific amount of points. So if I drag and drop this SL here, we can see there on the chart, we can see minus $280 or minus 280 points. And this is like the distance that we can use for our calculation. So we will have to calculate how much money we would lose if we only invest or if we only trade like 0.01 lots. And this is why we need these three values here. So we can say the money per lot step pretty much. Or we can just say money lot step. So if we trade 0.01 or whatever is the smallest possible lot step or volume step, how much money would we lose for the distance that we want to trade? Like for the amount of points starting from the entry to the SL. So we can calculate this using these values here. So we can say something like we first of all have the SL distance, which might be something like 0.00280, like this, for example, because this was the example that I chose. And now we will have to divide this by the tick size. So the result from this calculation will be the amount of ticks, which is in this case 280. And we can now multiply this with the tick value. So we know how much money we would lose for the whole distance if we would trade a complete lot. But we can still multiply this with a lot step. So if we only trade like 0.01 lot, we will break it down to this lot size. And because this is hard-coded and not really useful, we will add another parameter for this to the function. So we say something like SL distance. And we can add the SL distance here. So if we compile this, we will now have the risk for the smallest lot step. So if we print this, or let's print the two values here, the risk and in money and the money lot step. And of course, we will have to add the distance here. Let's stick to this example, 280 points or 0.00280. If we compile this, we can now see that we would lose $2.80 if we would trade this distance using 0.01 lots. And if we drag and drop this, we can see this is correct, because if we trade a complete lot, like we did here in this example, we would lose $280, but if we only trade 0.01, we would lose $2.80. And we can now, the rest is pretty easy, because we can now take the first value and the second one, and we will look how often we can put the second one into the first one, pretty much. And this is what we will do in the next and I think last step. So we can now calculate the lot step as follows. So we say the lots that we then want to open, we say risk money divided by money lot step. And we then multiply it with the lot step again. Because this will give us, if we do not divide it, we can see the result, lots. So if we compile this, we will see something like 30, which is like we can put 2.8 30 times into 85. And since this is the amount that we would risk for one lot, we will now have to multiply it with the lot step again. So we can say multiply it with lot step like this. And this will be the lots that we should trade for this distance if we want to risk 0.5%. And since there are too many numbers after the decimal point, we can use another function, which is the math floor function, which will round the result from this calculation down to the next integer value. So this will give us a rounded result now that we can trade. Okay, so this is pretty much it. And before we do this calculation, we should check if money lot step is equal to 0. Because in this case, we want to return 0. Because if we divide by 0, there is, of course, a critical error. Because you cannot divide by 0. So whenever you divide something, you should check if you might divide by 0 and catch this error before it can happen. And yeah, so this will calculate the lot size. So what we can do here is we can just return the lots from this function, and this is it. This is a complete calculate lots function that you can use. I mean, you can copy this and paste it in any of your programs. And this is really cool, I think. So if let me show you that this actually works. So we will do a test here. So we include the trade.mqh file here, and we can now open a position. So we can say ctrade trade, and now we can say trade by, and we can say trade by, and come on, give me the parameters. Okay, so first of all, we will have to provide the lots. So we say lots, and we can add the lots that we calculated using our calculate lots function as a first parameter for this by function. And of course, this only makes sense if we have a stop loss. So we will have to calculate these things. So first of all, we will have the entry, which will be the ask price. We can get this using the symbol info double function. And then we should round this, so we do not get any problems. And then we calculate the SL. The SL can be the entry minus, for example, 280 points to stick to this example. And we should, of course, round this. And now we can do something like, for this calculate lots function, we can say we want to have the entry minus the SL, because this is the distance of, the SL distance that we use for this calculation. And we can just hard code this at the moment because, yeah, it's just an example to show that this actually works. And then we can provide the entry and the SL here, and we do not have ATP. So if we compile this program and run it in the strategy tester, we should see that it hopefully works. So let me clear this up and open the tester, click on visualize. Oh, if you did not open the tester, you can click on view and strategy tester to open or close the strategy tester. Then you can click on overview, visualize, choose the program here, which is percentage risk. and then we can just start this because we are just simulating this. So we should see that we now risk 1% of this account, and in this test it is a $5,000 account. We were not able to open this position because the market was closed. Okay, so we oh man, we have to put this inside of our untick function, I think, and we can say we only want to do this if positions total is equal to 0, so we do not open multiple positions. Something like this, and now run the program again. Now we should open this position. So let me clear this. And now once the test is loaded, we should see this buy position. And whoop, this is fast. Oh, it was stopped out several times. Okay, but you can see now we open at the current price. We have 280 points for the stop loss, and we calculate the lot size. So for the first trade, it was 0.21 and then was 0.21. And now it is even decreased because the first two trades were losses. And therefore, we lost about 0.5% of this account. Oh, and there is a little bit, the loss is a little bit higher. And this is because of the commission. We did not calculate using the commission. So this commission comes on top. So the risk that we calculate, like this 0.5% of the account, it is only like the profit of the trade itself. But we have to add the commission afterwards. But you can see we always lose like $50, and this will the lot size will become smaller as soon as the account value drops. So you can see this pretty much works. So like right now in the end we have a account value of like 3,600 roughly, and we use or we lose €35, which is about 1% of this account. So you can see that this is working, and I think this is pretty much it. So this is how you can calculate the variable or the risk in percent. So there's always a small deviation from this value because we have the commission and slippage and something like this. But this is a function that you can use in any program pretty much to calculate the lot size if you want to trade with a risk that can be defined in percent of your account balance. Okay, so I hope you liked this video. If you did, make sure to leave a like and subscribe to the channel because I will post more useful stuff about programming for MetaTrader 5 and maybe even MetaTrader 4, I'm not sure. So and if you know someone who might be interested in these kind of videos, make sure to share the videos with him. And in the end, there's nothing more to say than have fun with this function and with programming for MetaTrader 5 in general, and we will see each other in the next video. So until then, have a nice time and good trades. Bye-bye.